let's work on the Bifrost Graph portion. So we go to Windows, Bifrost Graph Editor, and I've got a number of editors already here, graphs I've already created. I'll just click on create a new graph and you'll see something like this. Let me just move this, dock this over here. So you just have an input and an output. We don't need this input. We're going to create our own. And the inputs we'll have are pieces of geometry that we've got and have animated already. So demo SOMA, middle mouse drag it in, main axon, second branch, middle mouse drag it in. So the main thing we want to do here is to convert each of these to a volume and then convert that volume to a mesh and then output that into the scene. And the goal is by converting to then these to volumes and merging those volumes together, when it comes back to a mesh, they will actually merge together rather than just overlap like this. So there are a number of different ways you can turn something into a volume here. And the one I'm going to use is level set to mesh. But just so you know, there is also convert to volume and mesh to volume. I don't see it here. Mesh to volume. And they all work a little bit differently. But let's just stick to the one that I'm using here. So if we do level set to mesh, okay, I'm not seeing it here. Oh, sorry. Mesh to level set, because we're starting with the mesh. And if we just look at the info for this, this node voxelizes the input mesh geometry. So voxelize turns it into a volume. So we'll connect mesh to mesh here. And if we just connected level set to the output here and hide the geometry, then it's just creating this voxel version of this thing, which is not what we want. But if we go to volume to mesh, then we can connect this volume to here and this mesh here, and then we get a new piece of geometry. And it's nice and smooth. But that's just to do it for one. We want to do the same thing for each of these pieces of geometry so they can merge together. Let's look at the parameters first of the mesh to level set. The detail size, if we change this to a higher value, you can see we don't have as many edges, so it can't make the smaller shapes. But in our case, that might be okay, because we don't have many shapes in here, it's just a sphere. So you can play around with this. The volume mode, we can go from solid to shell, and shell just sort of expands the surface rather than making a solid voxel. And we can turn adaptivity on, so it will adapt as changes are made. But it'll make more sense once we do this again. So I'll just duplicate this. So copy and paste, and I'll connect the main axon shape. So it'll override this connection. And now we have to merge these two volumes. So we'll do merge volumes here. And we'll connect this level set. Then this level set. Then these will go to the volume, and we'll disconnect the original. So we can see that we've got the input shape. It's being converted, it's being voxelized. This input shape, it's being voxelized. We're merging those two volumes, and they're both going into the volume to mesh, and we get something like this. So now it looks as if they're connected. Okay, let's do that with the last one as well. So we'll just copy and paste this mesh to level set, replace the mesh that's going in, put it in our merge to volumes node, and it's already connected up. So now we get a nice connection here. Save your scene because things crash. And if we just back it up, you'll see there's a problem where that secondary branch starts. That piece of geometry is already there. Because if we'll remember, if we go back to the secondary branch, to the subcurves, we didn't want to go to, so this subcurves is allowing it to grow out. And when we put it at 0, it caused some errors, but keeping it something smaller than 0 puts a piece of geometry in the scene, which is kind of a problem, and we'll see if we can solve it. So we just play the animation, right? We get a nice animation here. And we can go in and tweak things. So in the merge volumes, adaptive voxel scale, I don't know what that does. Just so you know, in the merge volumes, you can change these to subtract, divide, multiply, and so on. So you can actually do sort of booleans with this as well. If you want to cut out a piece from the volume, it could be really handy. It's interesting. So optimized adaptivity. Let's play it now. So I'm just looking at ways that can minimize that shape. Let me just hide the original. Okay, so with it hidden, we're not seeing it anymore. It starts to form a little bit too early. Let's reduce this. So we're in the merge volumes, optimize adaptivity, adaptive voxel scale. I'm trying to turn this up to a value that minimizes this shape here without ruining the rest of the animation. So it's still there. The animation looks pretty good. So let's try. So it's still there. So if I go up to a really high value like 2, it's gone, but now this isn't working very well. We can try and turn this back to solid. So this is the Soma shape mesh to level set. I changed it back to solid to see if that would solve things. And this is pretty good. It's not exactly great. And you can see it sort of jumps ahead there. So maybe 2 is just a little too high. So what if we go to 1.6? Still see a little piece of that thing there. So 1.7, it's gone. And this can be a combination. So this is an adaptive scale. So if I go back into the original main axon shape, and then the detail size is 0.2, let's say if I change that to 0.4, then that's a little bigger. I don't really like that 0.1. So go down to 0.1, now we're starting to see those tears in there. So 0.4 seems to be correcting that. And now if it's too thick here, we could even go back to the original shapes that we made this out of. So NURB circle 3 is the circle that defines the shape of this axon. So I could even reduce its scale to get the shape that I want. I don't want to go below 0 here. Yep, so it's saying it could lead to strange results. Classic Maya. Save. Okay, so we're getting, it's a little rough looking. And then this is growing out here. It's maybe a little too rough looking. So if I go back to my merge volumes, if I change this back to 1, and I go back, see, I'm jumping all over the place here, obviously. Actually, that looks a little better. So this is the main axon mesh to level set. I reduced the detail size to 0.1. And then for the secondary branch, it's at 0.2. Change that to 0.1. And it's much bigger now because I reduced the size of the circle for the main branch, maybe a little too much. So I'm going to make it a little bit bigger, so it matches a bit better. But that piece of geometry is back. So you can see we're kind of playing a little tug of war here, trying to get this to be as good as we can be. Now, if it came to it, I could even hide this in post just by masking it out. But there's another trick we can try, although this is something that I've noticed is quite crashy. So let's go back here. I'm going to save my scene. And the thing we could do is actually take this original circle that made this geometry and key it so it's very small at the beginning. So the geometry will be smaller. This, for some reason, is very crashy. But if I go here to, let's say, frame 58, and I change the value of this to 0.1 and key it. Just key selected. And then I already have it keyed at the other sides here. I'm going to make it a little bit smaller. Save. So you can still see there's a tiny bit of geometry there, but it's maybe something you could live with. Okay, that growth looks good. And it gets down here. Then the second one should start to grow. That's a weird little transition there. But the growth itself looks pretty good. Now it's cached so we can watch. I'm going to right click on here and playback speed. Play every frame, max real time. Yeah, so there's a strange little thing going on here, and I might just make sure this isn't too small. Maybe that's... It's got to recache now that we've made that change. Okay, it goes through that same little thing with the animation. I can pretend I did that on purpose. It looks good. It's like anticipation of that thing happening. Okay, so now that we've got that done, everything is merged together. We have to turn this into a piece of geometry in the scene. This is a Bifrost Graph node, and you can see it here in the outliner. We want to turn this into an alembic file so we can take it into other Maya shots. So what we need to do is to turn this into actually a Maya node. I think the reason for this is that Bifrost is meant to be something that Autodesk can use in many of its applications. So it's, I think, meant to be application agnostic. And so to turn it into an actual Maya node, we have to go through a couple of kind of strange steps. So to do that, we can go to the node editor. Just empty this out, don't crash. And we want to bring in the Bifrost Graph 4 node. We got the shape node here. Hit tab and we'll create something called Bifrost Graph, Bifrost Geo to Maya. And this is a little tricky. What do we have to connect here? I think we have to connect meshes, yeah, to this. Still nothing in the scene. We have to give it a shape node. This is the strange part. So we can create a poly sphere. Actually, I think it's easier if I just create one this way. Just create a sphere, and there it is. We can delete the transform node. We've got the shape node here. We can just connect Maya mesh from the Bifrost Geo to Maya and connect it to the in mesh here. And if I just hit W, I can move it over. So now this is actually a piece of Maya geometry, and I can rename this growing axon. I can name it here. Okay. And if we play the animation, it inherits that animation, which is great. You can see that piece of geometry is here. I don't think I could delete it without causing major trouble. I could try. What if I go to face and delete those faces? Oh, they come back. Okay. So that doesn't work. I'm going to undo that. So now that we have this as a separate piece of Maya geometry, what we're going to do is export this as an Alembic file, and we'll do that in the next section.